Imagine knowing that in just a few hours you are going to die and there is nothing you can do to stop it. Vladimir Komarov falls toward Earth. His parachute fails, his final angry transmissions echo. Other tragedies flash silently, depressurizing spacecraft, exploding shuttles, unaware astronauts. These are not accidents, but horrifying deaths. How did advanced missions become death traps? Were these accidents or preventable disasters? In one case, astronauts never knew they were dead. To understand this, we go back to the space race. During the space race, political pressure overruled safety. Case 1, Vladimir Komarov, Soyuz 1. Vladimir Komarov knew the spacecraft was unsafe long before the launch began. Engineers had already identified more than 200 serious technical problems, but political pressure forced the mission to move forward anyway. His close friend Yuri Gagarin tried to stop the launch because he understood the risks and feared losing Komarov. Despite these warnings, the decision was not changed. When the rocket finally lifted off, problems started almost immediately. One solar panel failed to deploy properly, which reduced power and disrupted critical systems. The spacecraft began losing stability and started spinning uncontrollably in space. Komarov struggled to regain control using manual systems while fuel rapidly decreased. As conditions became worse, Mission Control realized the situation was critical and ordered an emergency re-entry, even though the chances of survival were extremely low. Case 2, Soyuz 11 crew. The Soyuz 11 mission started as a major achievement in human space exploration. The crew successfully reached and occupied the first space station and spent 22 days conducting experiments and collecting valuable data. Everything appeared normal throughout the mission, and communication with ground control remained stable and positive. The crew was confident and proud of their success, believing they would soon return home safely. When the time came to leave the station, the process was smooth and without any visible issues. The spacecraft separated correctly and began its descent toward Earth. All systems appeared to function as expected, creating a sense of calm and safety. However, this normal appearance was misleading because a hidden technical failure had already occurred, silently setting up a deadly situation that no one on board could detect or respond to in time. Case 3, Challenger disaster. The Challenger mission was one of the most widely followed space launches, especially because it included Krista McAuliffe, a teacher selected to inspire students around the world. Before the launch, engineers expressed serious concerns about the unusually cold weather conditions. They warned that the rubber seals in the solid rocket boosters could fail under such temperatures, creating a dangerous situation. However, management faced intense pressure to continue the mission and avoid further delays. This led to a conflict between engineers and decision-makers. Despite the warnings, the final decision was made to proceed with the launch. As the shuttle lifted off, everything seemed normal at first. The engines operated correctly, and the vehicle began ascending into the sky. Spectators watched with excitement, completely unaware that a critical failure had already begun developing within the system during those first moments. Case 4, Columbia disaster. During the launch of the Columbia shuttle, a piece of foam insulation broke off from the external tank and struck the wing of the spacecraft. Although this event was recorded, it was not treated as a serious threat because similar incidents had occurred before without causing major damage. Some engineers suspected that the impact might have created a dangerous weakness and requested detailed inspection images from external sources. However, their request was denied because leadership believed that no effective repair options were available, even if damage was confirmed. The crew continued their mission without any knowledge of the potential danger. For 16 days, they carried out scientific experiments and maintained regular communication with ground control. Everything appeared completely normal and successful. Yet, unknown to them, their spacecraft had already been critically compromised, and the real danger would only become visible during the final stage of their journey. Case 5, X-15 flight, Michael Adams. Michael Adams was a highly skilled pilot selected for an experimental flight program designed to explore the boundary between Earth atmosphere and space. His mission involved reaching extremely high altitude and testing advanced flight systems under near-space conditions. The flight began smoothly as the aircraft accelerated and climbed to its planned altitude. Beyond the atmosphere, traditional flight controls became less effective, and the aircraft depended on specialized systems to maintain stability. During this phase, a subtle control malfunction began causing the aircraft to slowly drift off its intended path. Adams did not immediately recognize the seriousness of the issue because the environment made it difficult to sense changes in motion. As the aircraft began descending, the problem intensified and control became increasingly difficult. Eventually, the situation escalated beyond recovery, leading to a catastrophic failure that Adams could no longer correct in time. But this was only the beginning. As Vladimir Komarov prepared for landing, the most dangerous phase started. The parachute system, which was supposed to save his life, failed to deploy correctly. The main parachute became stuck and did not open fully. What happened next was even worse when he attempted to use the backup parachute. It became tangled with the first one, creating a complete failure of both systems. The capsule continued falling rapidly toward Earth with no way to slow down. Inside the spacecraft, Komarov understood exactly what was happening and realized there was nothing left he could do to survive. But this was only the beginning for the Soyuz 11 crew. As their spacecraft began its descent, a silent and invisible danger emerged. A pressure valve suddenly opened, allowing air to escape into space. What happened next was even worse because the cabin depressurized so quickly that the crew did not have time to react. They were not wearing pressure suits, which meant they had no protection against the vacuum. The crew unknowingly began to suffocate, losing consciousness within seconds, while still strapped into their seats. Everything appeared normal from the outside, but inside the capsule, a tragic and silent disaster was unfolding. But this was only the beginning. During the Challenger launch, as a small but deadly failure began to grow. The rubber O-ring seal failed due to the cold temperature, allowing a flame to escape from the rocket booster. What happened next was even worse as the flame intensified and began to burn through the structure connecting the booster to the fuel tank. The situation escalated rapidly as the external tank weakened under extreme heat and pressure. Within moments, the entire system was on the edge of collapse while the shuttle continued climbing higher into the sky, unaware that a catastrophic explosion was now inevitable. But this was only the beginning when Columbia started its re-entry into the atmosphere. At first, everything seemed normal, but what happened next was even worse. As superheated air began entering the damaged wing through the hole created during launch, the temperature inside the wing rose rapidly, destroying internal components. Systems began failing one by one. Sensors showed abnormal readings, but the crew did not fully understand the severity of the situation. As the heat spread, the structural integrity of the wing weakened dramatically, pushing the spacecraft closer to complete failure with every passing second. But this was only the beginning for Michael Adams as his aircraft began to spin uncontrollably in the upper atmosphere. The control system failure caused the vehicle to drift into a dangerous orientation. What happened next was even worse. As the aircraft entered denser air, the forces acting on it increased rapidly. The spinning motion intensified, and Adams struggled to regain control while experiencing extreme G-forces. The stress on both the aircraft and the pilot continued to rise, pushing the situation beyond safe limits. As the aircraft lost stability, it moved closer to a catastrophic breakup that could no longer be prevented. At this moment, everything changed for each of these missions. Komarov was falling toward Earth at over 250 miles per hour. His final words were recorded as he faced the inevitable impact, ending in a fatal crash. Soyuz 11 completed its descent perfectly, but when the capsule was opened, the crew was found dead inside. Challenger exploded in mid-air, yet the crew cabin survived briefly before falling back to Earth. Columbia disintegrated over Texas during re-entry, scattering debris across a wide area. The X-15 aircraft broke apart at high speed under extreme forces. In many of these cases, the astronauts never had a chance. The truth behind these tragedies was not just technical failure, but human decisions. Komarov flight continued despite clear engineering warnings due to political pressure. Soyuz 11 disaster was caused by a faulty pressure valve combined with the absence of protective spacesuits. Challenger failed because of an O-ring that could not function properly in cold weather, yet management ignored the engineers' concerns. Columbia was destroyed because foam damage was underestimated and inspection requests were denied. The X-15 accident resulted from a control system malfunction without adequate backup systems. Most of these tragedies were not surprises, they were warnings ignored. This story shows us something important. Space is naturally dangerous, but human decisions made it even deadlier. In many cases, realizes the technology itself was not the only problem. Leadership failures played a critical role. Each tragedy forced major improvements in safety procedures, design standards, and mission planning. These painful lessons helped make future space missions safer for astronauts around the world. These astronauts did not just lose their lives, they contributed to progress that continues to protect others. Their sacrifices changed space exploration forever, and their stories remain a powerful reminder of the responsibility that comes with pushing the limits of human achievement. Which of these stories shocked you the most? Each one reveals a different side of the risks involved in space exploration. If you found this video interesting, you should watch our video on the most dangerous space missions ever, where we explore even more extreme moments in history. Subscribe for more real stories from history, and I will see you in the next video.